Now we're going to see the equation of a plane and of a line. I don't know if I was doing it in this same video or in the other, it depends on the time. Alright, first, when we want to know the equation of a plane, we need two things. We need a point that we know that is in the plane, and the direction of the plane. It's kind of like the same when we want to know the equation of a line. We always take a point that we know that is in the line and the slope of the line, and like that we can calculate the equation of the line. That's simple math. Now when we want to calculate the equation of a plane, we want to know the same, a point that is in the plane and the direction of the plane. That would be, let's say that the equivalent to the slope here would be the direction in this plane, in this plane, in this plane, in which plane we are, because the point could be in this plane, would be in this plane, and this is the same point, but in the plane in which this point is in a different plane, because the direction of the plane is different. So we need a point, and direction of the plane. So let's say this is the plane, and we know the point PO. PO has components x naught, y naught, c naught, or you could say x0i plus y0j plus, y0j plus k0 plus ck plus c naught k. Alright, now we are going to do a vector that is with some other point that is in the plane. Here we have now this vector that is in parallel or in the same direction as the plane. So we have the vector P of P is equal to P has components x, y, z. So it would be x minus x naught. You could say this I plus y minus y naught, j plus c minus c naught, k. Now this is the equation of the vector. Let's say the components of the vector from PO to P. Now the direction. A way to know the direction is we have the direction of the plane. We know that the plane has a normal vector, that is the vector that is orthogonal to the plane. We have this plane, this is the normal vector. I have this plane, this is the normal vector. So this, if I have this plane, goes through the screen. So I have a normal vector here, n, and let's say that these coordinates are ai plus bj plus ck. So what do we know? We know that the dot product of POP of this vector dot the normal vector is 0 because they are at 90 degrees. So we have normal vector dot vector POP is equal to the magnitude of n times the magnitude of POP times the cosine of 90 degrees. So this is equal to 0. So I have n dot POP is equal to 0. Now let's dot n and POP. We already saw that would be just the components. We already saw that actually is dotting each component with each component, but because the I dot k and I dot j and j dot k die, and so we just left with the component I times the component I plus the component in j times the component in j plus the component in k times the component in k, and k dot k, j dot j, and I dot I is 1. So it's just the let's say the constants multiplying in each component, corresponding component. So we have a x minus x naught. Here I have x minus x naught, I y minus y naught, j c minus c naught. Okay. So I have a times x minus x naught plus b times y minus j naught plus c times c minus c naught equals 0. Now this x naught is just a number. Here exactly the point P is, let's say, 2, 3, 4. So it's just a number. These are constants. When we multiply that by a, b, and c, because we know the normal vector, here also these are constants. So a times x0, b times j0, and c times c naught are constants. So at the end we have ax plus by plus cc equal some constant. That would be, here is minus ax minus by minus cc, so it would be d, in this case would be ax plus by plus cc. Correct. This is an equation of the line, of a plane. This is the standard equation of the plane, or you could say this is the standard equation of the plane. Here you know that this plane is the plane that passes through the point, or contains the point x naught, y naught, x naught, y naught, c naught, and that the direction is perpendicular or orthogonal to the normal vector a, b, c. So like this you know the plane. And now look that the plane has 2 degrees of freedom. When you say the x is 9 and b is 10, how is, or what is c? That is, you have you already know that a, b, and c, what are they? You know what x naught, y naught, and c naught are, so you know what's d. Here when you put x equals to something, y equals to something, you just need to find for c. So you have 2 degrees of freedom, because if you just know x, you know anything about y or c. Well, you don't know what are they. If you know x and you know y, you know what c is, or if you know y and c, you know what x is. So the plane is a linear equation with 2 degrees of freedom. It's very important. You can have many linear equations in many, or a linear equation in many dimensions. This is a line is a linear equation in 2 dimensions. A plane is a linear equation in 3 dimensions. You can have a linear equation in 15 dimensions. So that's just that we cannot imagine.